Hello, Dr. Alvaro. It is Noah,
And Connor Simone.
and we are doing our third take on showing you what we've been doing for assignment 1. So if we go into the scene real quickly, we have the Goose, who is a player model, and he's moving around, and he is able to shoot a gun. So, going through everything that we've done, we will go for the command method first. So how's the command method work? Well, basically what we're doing is we have our command class is making a pure virtual function. In C# that does not translate into pure virtual. It's more so an abstract class that, and it doesn't have to equal 0, but we're putting in the objects and classes that we need to change for execution. So when we go into these different classes to do these different things, they will then do the functions for the objects that they are triggered to. It's like having a TV remote and selecting certain channels, and like telling the TV to select certain channels. So we have BT for back in time, and then we have MS for movement script. So if we go into the input manager, we have these coming in as public command objects, and then we are assigning them via what their respected objects are. So when we have things like input get key P and H execute, it will be doing the mirror command because that's the class that it is overriding. And the same thing for these as well. So once we go into that, we can see that we are, let's do mirror script for example. If I hit P, then I can invert my controls. I'm just hitting D here, still hitting D, still hitting D. And what I did there was I actually inverted the controls. If we went into the movement script, which is something that I took from an old game jam that I did, we will see that he has just moved based on the mirror walk function, and all that mirror walk is doing is it is changing a 1 to a -1. So it's inverting things. If you move forward, you're moving backward. If you're moving backward, you're moving forward. We could also use this to change, let's say, the get key or the input key, or we could even throw that into a function above in the input manager itself. But we can still see very clearly that we are using abstract classes to then command and override for the command method. So next we're going to look into how we are undoing a function. So Connor, do you want to show how you're doing that?
Yeah, so when we actually go into the scene here, you may have not expected this, but the Goose actually has mastery over temporal and spatial anomalies, including itself. So all you need to do is hold the T key, and he just goes back and reverses everything. It's incredible. What a legend. Anyways, so how are we doing this? It may be simpler than you'd think. You go inside of Visual Studio, and you check out this script. So, starting from the very beginning, we use this custom class called point in time. It just stores position and rotation. Then inside of here, we are creating a list of that, call it temporal nodes. Just initialize it, do whatever. And you can see here in the fixed update, we have two functions that are important, rewind and record. So we're doing this in fixed update for two reasons. One, because reversing time as it is concerned with physics, and it's also nice because it has only 50 updates per second, like a constant 50 updates per second. In doing that, when we are recording, we're able to do a constant amount there, and then we are just inserting it into the list like it's a queue. And that is using the DLL function for get position and set position. And then just when it's rewinding, do the variables. When it's not rewinding, just reverse them. fairly simple overall, and obviously this can happen for X amount of seconds.
All right, so if we wanted to look really quickly into what's going on for the DLL, all we're doing is we're getting in and setting a vector 3, and so that is going into greeter. Don't really need to go into the H, but basically H just has definitions for position, which is vector 3, and then set position here, which is just taking in a vector 3 in E++. And then from there, we're sending that to the wrapper. This is using some of Chris's TA code, but we've modified it to fit the need of adding in the position. We could also do this for getting in the rotation, but this is more so for proof of concept. And you could use this for things like networking in C++, and sort of working between two different code bases. So yeah, once we do that, we wrap that up, and then from there, then we send it to the Hello World plugin wrapper, which is just importing the DLLs. Once we are done with the wrapper, then we make a build, and the DLL goes into the folder. The folder is basically then read by this script. And so it is then just getting in set position, get position, and that's about it there. So next we're going to go into the flyweight design. Now, Connor, how is that working?
So the way that flyweight design is working inside of here, we want to minimize the amount of calls that we have to do. So as you can see, over here, we actually have pre-initialized just X amount of bullets, right now 20 for demonstration. And so obviously when you fire one, it gets activated and it gets sent off using the initialization functions. But if you continue to fire them, you'll see that it eventually goes, and then that bullet far away in the distance disappeared. That's because it's not deleting after a certain amount of time. They're getting reused. So because of that, it's not going and actively calling the function to initialize a ton of them. Alternatively, we do also have a method for just shooting without this optimization.
Yes, so if we're hitting the V key, they'll make very fast bullets. The thing is, they're just instantiating and then destroying after 3 seconds. So it's really bad for optimization. If we pull up the properties bit, or sorry, the profiler, we can see a big spike when we are deleting and sending in these new ones, and then less of an impact with these ones. So that is that for there. We are just going through a list. If you want to see the code, you can, but really the bad bullets are just instantiating and destroying, and then the other ones are going through a list of things. So now, with 2 minutes left, hopefully we can get this through, otherwise we'll make another video for the rest, is the observation method. Basically, we are just using two scripts here. We have the cube, which is the script to be observed, and then the barrels here. So if I were to shoot this barrel, it would then move, and then things around it would move. So if we look into those scripts really, really quickly, we have the observed cubed and the observed change. So the observed change is on the cube. It has these variables on it. Main ones are the checker, members, and members through. So basically this one's just saying, has a on collision enter thing, and it's setting checker to true. It is also doing some movement stuff, but that's not too important. If we then look onto the scripts that are on observed cube, then we will see that local position, these are changing based on the the cube.color, which was just another variable that was shifting it around. And then if checker is true, then it's doing this function, observe change, right? So it's checking a thing that it is attached to, and thankfully with Unity we can actually do this where we just drag and drop the cube object of the cube observe change script. Alrighty, I think that's actually all that really is needed to be shown. You'll see the rest of the stuff in the contents, and we hope you enjoyed.
Goodbye.